Hey everyone! Welcome back to the channel Bug no Jutsu, where we break down complex coding problems into simple and easy-to-understand solutions. Today we're tackling an interesting SQL problem from LeetCode, problem number 577, called Employee Bonus. We'll solve it step by step, explain it thoroughly, and also solve it in Pandas. If you're preparing for data analytics, SQL interviews, or even data science roles, this video will really boost your understanding. So stick with me till the end and let's dive right in. Alright, let's begin by understanding the problem statement. We are given two tables. The first table is called Employee. It contains the following columns. Employee ID. This is the unique ID for each employee. Name. This is the name of the employee. Supervisor. The ID of their manager. Salary. The salary of the employee. The second table is called Bonus. It has YEMP ID, Employee ID, which acts as a foreign key link to the employee table. Bonus, the bonus amount that employee received. Now here's what we need to do. We have to write a query to find the names of employees whose bonus is less than 1,000, or those who didn't get a bonus at all. Let's break this example down in a simple real-world way. Imagine you work in a company with 4 employees. The first employee is Brad. He's a senior employee and actually he doesn't have any supervisor. His salary is quite high, around 4,000. Next we have John. He works under Brad and earns a salary of 1,000. Then there's Dan, another employee working under Brad, and his salary is 2,000. Finally we have Thomas, who also reports to Brad and earns a salary of 4,000 just like Brad. Now let's move on to the bonus information. In this company not everyone gets a bonus. Dan received a bonus of 500, great for him. Thomas received a big bonus, 2,000. But what about Brad and John? Interestingly, neither Brad nor John received any bonus at all. Their names are not even listed in the bonus records, which basically means they didn't get anything. Now here's what we're supposed to do. We need to find all employees who either didn't get a bonus or whose bonus is less than 1,000. Let's check.
Dan S bonus is 500.
That's less than 1,000, so we include him in our result. Brad and John didn't get any bonus. They're missing from the bonus records. We also include them because no bonus means they qualify too. Thomas, however, got a bonus of 2,000, which is more than 1,000, so we skip him. In the end, the employees we report are Brad, John, and Dan. And we also display their bonuses. Brad and John show no bonus, so we display it as none or null. Dan has a bonus of 500, which we show as is. That's exactly how we solve the example. Now let's talk about how we solve this problem using SQL without jumping straight into the query. The main goal here is to find employees whose bonus is either missing or less than 1,000. We have two tables, one for employees and one for bonuses. The tricky part is that not all employees have a bonus entry in the bonus table. Some employees just don't get any bonus, so their names aren't even present there. If we simply join both tables directly, like with an inner join, we'll only get employees who actually have bonus records. That means employees without bonuses would be completely left out from the result. But we don't want that. We specifically need employees without bonuses too. This is exactly where the left join comes in. A left join helps us merge the two tables in such a way that all employees are included from the employee table, even those who have no bonus records. For those employees without bonuses, their bonus value will appear as null in the result. Once we've combined both tables this way, we just need to apply a simple condition. We check for employees whose bonus is less than 1,000, or whose bonus is null, which basically means no bonus. This gives us exactly what we want. Employees with low bonuses. Employees with no bonuses at all. In the final result, we simply show the employee name along with their bonus amount, which could either be an actual bonus value or null if they didn't receive anything. And that's how we solve this problem with SQL, by using a left join to include everyone, and then filtering based on the bonus value. Now let's see how we can solve this same problem using Pandas in Python. Just like in SQL, we have two datasets here, one for employees and one for their bonuses. The first step in solving this is to combine both datasets. In Pandas, we do this using something called a merge operation, which is very similar to a SQL join. But here's the important part. We need to make sure that all employees are included in our result, even those who didn't get a bonus. To do that, we use what's called a left merge. This merge keeps every record from the employee dataset, and it tries to bring in the matching bonus from the bonus dataset. If an employee doesn't have a matching bonus, the bonus value will just be shown as missing. Pandas will display it as NaN, which basically means not available. After merging the data, we now have everything in one place, each employee along with their bonus, if they have one. Next, we simply apply a filter on this merged dataset. We look for employees whose bonus is either missing, which means they didn't get any bonus, or those whose bonus amount is less than 1,000. This filter gives us exactly the employees we are looking for. Employees with no bonus at all. Employees who received a small bonus, less than 1,000. Finally, we just pick the columns we care about, namely the employee's name and their bonus, and return this result. And that's it. This is a very common workflow in data analysis. Merge the data. Filter it based on some conditions. Select the columns you need. With just these 3 simple steps, we solve the entire problem in Pandas. Left joins are extremely powerful when you need to retain unmatched rows, especially in reporting tasks. Knowing when to use null checks and conditions together is critical for correct data queries. This problem also teaches you the importance of merging/joining datasets properly in both SQL and Pandas, a crucial skill for data analysis and data science interviews. Lastly, it shows how SQL and Pandas can solve the exact same problems, just with slightly different syntax and methods. And that's a wrap for today. If you enjoyed this breakdown, like the video, subscribe to the channel and drop a comment. I'd love to hear your thoughts. Thanks for watching. Until next time, keep coding, keep growing, and as always, stay awesome.